Okay, so what are we here to talk about today? AI and digital twins. How do we make this a little bit more real and a little bit less nebulous? Because what is a digital twin anyways, right? So here we are. First of all, we're going to talk about AI. This conference is mostly about AI, and we're talking about how AI is being implicated in a new class of products. So I come out of the refining industry, and by the way, if you don't know me, my name is Peter Reynolds. I'm an industry analyst here with ARC Advisory Group, and I've got some fantastic speakers here today. But I come from the refining industry where you have complex, high-value assets and things that are safety is absolutely important. So thinking about AI is a topic that doesn't seem to go well when you think about optimization and safety. So in our research over the course of the last 6 to 8 months, we have studied the APC and the optimization market. And we've realized that there's a new class of products where AI is directly controlling DCSs and PLCs. So how do we do that? And it probably seems a little bit unbelievable. We're going to hear from our speakers today on how AI is an option for APC and RTO, and in some case displacing those core technologies, and how companies are still struggling to address AI and harness its full capability, and how companies need to rethink governance in their operating models. So, why AI and process control technology? How many people here are involved in some way in the deployment of process control technology? Just a show of hands. Okay, that's a lot. That's about half. Thank you very much, right? So we already know that there's a shortage of certain skills across the industry, and one of those skills is APC engineers, right? So APC, while it's getting easier over time, we're still left with a shortage of skills and capabilities. Companies actually want to make better use of the data that they're already collecting. With sustainability at the forefront of investment strategies, companies really want to improve their margins much better. So they want more profits, they want fewer process shutdowns, they want to reduce energy, and they need tools to do that beyond the technologies that they have today. We know that there are limitations with some of the technologies that currently exist. So traditional optimization solutions sometimes have optimizations. Companies have really struggled. APC is one thing, and while there's a shortage of APC engineers, multi-unit real-time optimization has been a challenge. So there's been model fit challenges, a heavy services component on many of these technologies, and the rise of AI leads to new opportunities. You've probably seen a few of the surveys. ARC would like you to know that we are connected to users and we understand what users need. Well, no surprise that we surveyed 591 companies recently, and AI by far is far out in the forefront of all the other technologies. No thanks to ChatGPT and other technologies that made our CEOs and other executives really understand how AI can ultimately change the way that we work. So I want to talk a little bit about the new category that we created. So we call it closed loop AI optimization, and we put it along with the existing categories of APC and RTO. So APC, advanced process control, model-based control. It's a control of the continuous process or batch process using empirical, first principles, or hybrid AI models. That definition has long been accepted for decades, since the first matrix controller was developed. RTO, real-time optimization, that's continuously monitoring the state of multiple processes through a model reference to predict an optimum operation path, and there's technology for solving simultaneous equations. So closed-loop AI, on the other hand, is machine learning algorithms and neural networks. And some of you are going to say, yeah, we've been doing neural networks for 20 years as well, but there are new methods of deploying some of these technologies. So the neural networks are directly controlling plant operations, not just doing it in an offline environment, but they're providing the model predictions. So the techniques from AIO, or closed-loop AI optimization, they generate an intelligent entity which leverages the knowledge and experience acquired in training to take action in an environment to maximize the notion of a cumulative user-defined reward. And I know that that's a lot to think about. But what I want you to take away is the APC and optimization market ARC does study the markets, and you've probably seen some of our charts and what goes out. The APC and optimization market is roughly a $700 million market. 10% of this market now is comprised of the vendors that are doing closed-loop AI. So AIO might resemble APC. So I just want to highlight some of the differences. So MPC uses a mathematical model based on a physical system, and then it solves an optimization problem at each individual step. Okay, it's deterministic, it's time co-constrained, and has a short receding horizon. So AI, on the other hand, can be used to infer patterns in the data, often less structured, in an environment that's often without the help of the mathematical model. Many models can be contained within the scope of the AI. Decision trees, deep learning, and reinforcement learning techniques are all relevant, right? So these techniques can be non-deterministic. They're typically not limited to predefined horizons and typically improve with more data and training. So what's happening here? Why is AI closed-loop optimization? Is it going to come quickly? What are their barriers and their drivers? So we know that AI optimization is different. Some companies lack adequate change methodologies. There are immature internal processes to be able to leverage AI, because AI is different than APC. It's a different workforce that's implementing these technologies in many cases. There are data quality issues that exist. The variables associated with building a matrix controller or an MPC optimization controller, the data quality is relatively small, and the data qualities are more easily solved, right? And moving data to the cloud, there are IP and cybersecurity posture concerns, right? So what you'll learn today, some of this actually has to happen in the cloud, right? So drivers, so what's going to help AI come along? And well, we know that there's still a shortage of APC engineers, right? The cost of compute of AI advancements is the cost of compute. It's accelerating, and IT-OT convergence is actually working to find new sources of value. So the experience that the IT side of the house implementing AI is going to help the process control world, right? And AI is seen as pivotal and increased in adopting an increased level of autonomy in operations. So that's very important for many companies today. In terms of a little bit more on the differences, is when we look at AI-driven AI optimization or data-driven approaches, models and insights are typically statistical, right? And they use machine learning methods on empirical process data versus APC, which tends to be fundamental physical, chemical, or biological laws that follows these, such as thermodynamics and fluid dynamics. AI-driven approaches tend to be developed using data inputs without explicit knowledge of the underlying physical processes, and APC solutions tend to be more based on with explicit knowledge of the physical process. AIO is highly flexible and more adaptable to new data, allowing for continuous improvement and learning, versus APC and RTO tend to be less adaptable to changes in process conditions that require tuning and rework of the model. AIO requires large volumes of data for accurate model development and prediction, and APC works with limited data sets if the fundamental principles are well understood. Right, so there's a lot of differences between these two technologies. So where do we think it's headed? We're going to see a couple of use cases today from Marathon Petroleum, but we think process control is just one piece of where AI is moving, right? So we created a new category. We saw AI was actually starting to replace RTO and an APC in some cases, but we see the AI across several different work processes and functional areas within a manufacturing organization. So in addition to process control, we see AI augmenting LP as a daily, weekly optimization tool. We see AI foundation models used for improved maintenance planning, thanks to deeper process insights. We see democratization of modeling among a number of users, unlimited number of users, and we also see it toward being able to help and identify instrumentation issues. We see more collaboration using the same data versus RTO and APC solutions. Remember, that's the APC engineer. It's relatively contained within an organization, and the ability to get access to that data tends to be limited to the APC or the RTO engineer and the operator. It's a little bit harder to share, right? So we see it for reliability improvements, helping with operator training, and identifying process improvement opportunities for capital projects. So when we look at across all the markets, and ARC studies over 100 industrial markets, we see foundation models in AI actually being implemented across many different areas where typical constraint planning models might exist. And we want to talk a little bit about governance. So I mentioned before about the compute and the experts, the APC engineers or the process engineers. We see AI optimization sort of at the center of kind of three different unique areas, right? So we look at data science and AI, not normally found at site, right? That comes from outside. Well, some asset owners do have data science organizations. They're typically very small and very focused, right? So you got the combination of parallel processing and statistics and machine learning, deep learning, neural networks, all of those skills and capability combined with what IT infrastructure or IT shared services typically focus on, which is things like desktop computing or mobile computing or distributed computing and managed services, right? So you combine that with IT software at scale with somebody that really understands the relationships and how process control or planning and scheduling or asset performance management. Somebody needs to understand how to use all of that, right? So that's the decades of experience that comes from the mechanical, the reliability, the process engineers. You bring all that together, and that's where you have AI optimization. So with that, there's a few important people that we want to introduce you to. So we're going to hear from a few change agents today, as we call them. These are early adopters of technology. So on one hand, we're going to hear from GT McDaniel from Marathon Petroleum. And then we're going to hear from Geraldo Teixeira from Petrobras and Flavio Waltz from Ernst & Young Brazil. They're going to present to you AI optimization and then the governance and the structures around how to start to create value between IT, OT, and then ET. And then after the presentations, then we're going to have a very, very interested and lively panel discussion. So with that, please join me in welcoming GT McDaniel to the stage.